Hey Mary Pat, I'm sad you're not here today, but I am excited to try this video thing out. So let's start by looking at the homework we had last time. We were naming alkane organic molecules, and so we're going to start with number 1. Remember on these, you want to use your Greek prefixes. Okay, so there they are. So this very first molecule has let's get this going. 1, 2, 3, 4, 5 carbons. And if we think about how the hydrogens are arranged, we have a carbon, 2, 3, 4, 5. This one will have 3 hydrogens coming off of it. I'm not going to draw them, but that's where they would be. This one has 2, so that's good. This one has 2, that's good. This one has 2, and this one has 3. So it is just as written like this. So this is going to be the carbon with the 5 chains, and that is pentane. So let's look at the second one. It looks a little bit different. It looks almost exactly the same because we have 5 carbons. 1, 2, 3, 4, 5. But these parentheses suggest that something different is happening, and so does the different number of hydrogens. And actually, if you'll look closely, we actually have 1 extra carbon because this 2 here suggests we have 2 of this entire molecule. So we actually need to draw this out to figure what the name of this is. So let's go ahead and draw it from the start. We have that carbon with the 3 hydrogens. Then we have another carbon with 2 hydrogens. We have the next carbon, which, oh look, there's that weird parentheses thing. The fact that it's right next to this carbon means that those 2 carbons are coming off of it. So here's a carbon, here's a carbon. Each of those has 3 hydrogens. So that fulfills the fact that there are 2 of these CH3 molecules coming off of this carbon. Sorry, not that carbon, but this carbon, okay? Next, we have 1 final CH3, so it's going to go there. So this is our molecule, and we're going to name this the same way we do normally. We have to find the longest chain, and so if we were to do that, we would say we could either go this way, we could go this way, we could go this way. They're all going to be exactly the same as far as how long the chain is. See, I cannot undo that. That's very annoying. So we know the longest chain possible is 4, and then there's 2 methyl groups coming off of it. So the main part of this chain is going to be the one that's named with 4, and that is butane. Right, so butane is the carbon skeleton, and then we have 2 of these single carbons coming off of there. Remember, if it's a single carbon, it's called methyl, if it's acting as a functional group. So methyl, but there's 2 of them, so that is going to be dimethyl. Remember, it's not bi, but di. And we need to describe where it is on the chain, so we need to name this so that it starts at the lowest carbon number possible. So we could start here, 1, 2, 3, but that puts it at number 3. So instead, we are going to start on the other side, and it's going to be 1, 2, 3, 4. And so that'll make this 2-dimethyl butane is going to be the final name of number 2. It's like, all right, question 3. The first thing we need to do is find our carbon backbone. So let's look at that. We could go this way straight across, and that's going to be 1, 2, 3, 4, 5 carbons. Okay, oops. Here we go. We could go this way, and that's going to be 1, 2, 3, 4, 5, 6 carbons. So remember, we always want to do the longest chain possible, so we're going to do that. And it doesn't matter, you could go like this instead of doing that top one. You could instead go this way. Either way, the longest chain possible is going to be 6 carbons, and that is going to be the base of our chain, making this a hexane molecule. Okay, and then we need to talk about what functional groups are on there. So what do we have? We have a methyl here, because it's just 1. We have a methyl here, and we have a methyl here. So where are those? Let's count our chains. Let's count our carbons, sorry. We're going to have 1, 2, 3, 4, 5, 6 carbons. So there's how I would number them. So we have 2 methyls on carbon 2. So it's going to be 2-dimethyl. Oh, but then we have another methyl over here. So comma, 3, here we go, 3 methyl, and I didn't leave myself enough room. Let me go back and erase a little bit, okay? So 3-methyl hexane. So the name of this molecule is 2-dimethyl 3-methyl hexane. Okay, and the last of your assigned problems is number 4. So let's look at number 4. All right, so first of all, like usual, count your backbones. So let's see what we got. We have 1, 2, 3, 4, 5, 6. That looks like it is a reasonable number. There's nowhere we could go where we would get more carbons doing this. We would just get less if we went, instead of going across or up, we went across. We would get only 4 carbons. So our best bet for this backbone is going to be a 6-carbon chain going like this. Again, we could also go in this direction instead, but you can't go both. You have to pick one or the other. So I'm just going to keep it this way. All right, cool. So we have 6 carbons. So we already know this is going to be a hexane molecule again. Hexane. Cool. But that's not all. There's more going on, so we need to label those. And so it's kind of similar to the last one. In fact, it is almost identical in that there are, again, 2 methyls coming off of 1 carbon group. So remember, this is not an ethyl, okay? This is not an ethyl molecule because they're not connected together. They're connected independently. So first this one bonded and then this one bonded, or vice versa, okay, for all we know. So there's 2 methyls on this carbon and there's 1 methyl on this carbon. So how are we going to number this? We could number the carbons 1, 2, 3, 4, 5, 6, okay? Or we could start on the other side, and we want to start on the other side because that'll give us the lowest number. Again, we want to number our carbon backbone so that we have the lowest numbers possible, okay? So that means that this is carbon 1, carbon 2, carbon 3. Okay, then we get, so then we get carbon 4. Sorry about that. Let me go back to this. Carbon 4, carbon 5, carbon 6. Excellent. So what do we have and where do we have them? At carbon 2, we have a methyl group. So 2-methyl. We only have 1 methyl group there, so it's just 2-methyl, comma. And if you had enough room, you would write this in a straight line, remember? And then at carbon 3, we have nothing. Carbon 4, we have 2 methyl groups, so it's going to be dimethyl. There we go. Sorry about that. Dimethyl. So our final name for this product, or this carbon chain, is 2-methyl-4-dimethyl hexane. And the reason why we have to be so very specific on how we name this is because if you were just to give someone the name, they would have to be able to write the product as it is actually created. And remember, we talked about last time, if you change just one slight change in the chain, if you create one slight change in the chain, you can get very, very different biological reactions, if nothing else, and that can lead to disease. It can lead to birth defects, etc., and we do not want that. So it's very important to name your chains properly. Now, I only had to do problems 1, 3, and 4 as homework because we haven't talked about another way to write carbon products is to, remember I didn't want to write the hydrogens because, oh, what a pain in the butt. Who cares? They aren't that reactive. They bind to everything. So I just put little lines. Well, technically, if you're going to be lazy, you don't even write the hydrogens at all. And that's completely okay because chemists like to be lazy and do the simple thing. They want to get to the important part of the problem and not have to write all those dumb hydrogens. Well, they can go one step further, and instead of writing all the carbons, they'll do this shortcut where they draw lines instead. So starting in number 5, we're going to start working on what's called the skeleton models. And you'll see this is actually 2 ways to represent the same idea. So, okay, let's look at this. So what is up with this weird molecule? What is happening? So we definitely have our normal carbon chain here. We have 1, 2, 3, 4, 5 carbons. And then what's happening? Well, an easy way to be lazy about carbon molecules is to draw lines instead, suggesting or representing that there is a bond between 2 carbons. Okay, so here's a carbon. In the fact, we know it's bonded to a carbon here because by convention, instead of writing the carbon again, we just draw the line. Okay, so at the end of each one of these lines, there is a carbon like this. And bonded to every one of those carbons is enough hydrogens to make each carbon happy, so to fill in all of its valence electron spots, or sorry, covalent spots, so it has 4 bonds total. Okay, so this carbon here, it has 3 more empty spots because it only has 1 bond right now, so each one of those is bonded to a hydrogen. Same thing with this guy on this end. He's got 1 bond already. He can make 3 more bonds to make 4 total. Those will be hydrogens. This carbon here can have, he's got 2 bonds, so he can make 2 more bonds here. Hydrogen. Oh my God, I'm not writing all this. It's awful. Nobody wants to do that. Nobody cares about hydrogen. We care about all the other molecules except for hydrogen when we're dealing with any kind of organic chemistry, because literally all they do is fill bond space. So forget, I mean, they're important when we come to water, but we're not dealing with that yet. We'll deal with that later. So we just leave the hydrogens off when we're doing these skeletal models. So before we name this, I think I want to reiterate how simple a representation this skeletal model is. So we're going to look at number 1 again, actually, and create number 1 as a skeletal. So if you look at number 1, remember this was just a pentane. So if we were to take number 1 and turn it into a skeletal model, we would say, okay, I've got 1, 2, 3, 4, 5 carbons. So I'm going to add, you don't actually do this dot, but I like to do it because it makes me feel like I'm starting something. But we have, okay, here's a carbon, and then there's a second carbon, and a third carbon, and a fourth carbon, and a fifth carbon. And that is my skeletal model. That's it. If you want to be more accurate, you don't put that dot on the end. That's it. That is the skeletal model for pentane, because if we think about what's happening technically, we have a carbon, a carbon, a carbon, a carbon, a carbon, and that is a pentane molecule. Because again, we assume if it's not written, if there's nothing weird happening, we assume all the other molecules, all the other bonds are filled with enough hydrogens to satisfy the bond needs of carbon. Okay. Excellent. Hopefully not too confusing and weird. Let's go down and look at finishing the naming of number 5 now. Okay, so now that we know what the weird lines are, we know they're carbons, so now we need to find the longest carbon chain possible. So let's do that. I'm going to start here, and I'm going to go, okay, I've got 1, 2, 3, 4, 5. Cool. Oh, but it's connected to another carbon, so that's 6, 7, 8, 9. We have 9 carbons. Let me check. Sometimes I miss things. This happens a lot when you're dealing with these weird skeletal models. So I'm going to go backwards. I've got a carbon. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. Cool, I was right. That is the longest chain possible. So remember, the 9 carbon chain has the root nonane. Nonane. Excellent. That is a 9 carbon chain. So what else is happening in this molecule? The only other thing that we need to talk about is the final carbon group here. Okay, so what is happening? We know that, okay, first of all, let's number our chain, okay? So I could start here, but then that would not be correct, so I'm going to start on the other end. First, let me erase this. Okay, so I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon. So on carbon 4, something's happening. What is this? We know that this is a carbon, but if it's a carbon, we have to satisfy all 4 of its bonds. Okay, let me make this cleaner. Okay, so this is carbon 4. We know it's a carbon. We know it's a carbon that has 1 bond already fulfilled. It needs to have 3 more bonds. And since we don't have anything else written there, we know that those other 3 bonds are actually hydrogens. So here's a hydrogen, and a hydrogen. So what is the molecule that is carbon plus 3 hydrogens when added to a carbon chain? So added to the carbon here. Oh, it's methyl. So this is 4-methyl nonane. And that's it. That's all you have to do. The trick is just remembering to count each one of the points and the ends as individual carbons. So let's do another practice. All right, problem 6. Practice problem 6. What's going on? Again, if we have these weird spiky things, they just mean that they're carbon molecules added to, in this case, another carbon chain. Cool. So what's happening? The very first step, it's still the same as it always is. Count the longest possible carbon chain. Okay, so let's say I started here and I said, all right, I'm going to go this way. 1, 2, 3, 4, 5 carbons. Perhaps that might be my longest chain. But, that would be simple, and that's not how life works, so let's try again. Let's go this way. I have 1, 2, 3, 4. Oh, this is a carbon, so that's 5. And then I'm going to go this way, 6. So, because technically every intersection and the end of a line is a carbon. So there's a carbon, there's a carbon. So my longest chain is actually 6 carbons long, not 5 carbons long. So that makes this a hexane. We seem to have a lot of hexanes in this assignment. Whatever, that's cool. So that's a hexane. Excellent. So what have we not taken into account with this molecule? We have this group hanging off by itself, and we have this group hanging off by itself. So they're both single carbon chains, making them methyls. So we need to find out where they are. So we need to number our carbons. I'm going to go 1, 2, this is the second carbon, 3, 4, 5, 6. I want to make this more obvious that this is carbon 2, okay? Carbon 2. So the first thing we get, if we start at number 1, we hit carbon 1 has nothing else on it. Carbon 2 has this methyl group here. Okay, so since it's just a carbon off by itself, it's just a line off by itself, that actually stands for CH3, like we saw in the last problem. So it is a hexane molecule, but it also has 2-methyl. Oh, and is that it? No, there's one more thing. So then on carbon 3, so 2-methyl, 3-methyl, hexane. If you were to be given just the name 2-methyl, 3-methyl hexane, you would get something like this. You would draw the 6 carbon chain first, and then on carbon 2 you would add a 2-methyl group, so a CH group. On carbon 6 you would add, oh boy, let's start again. On carbon 2 you would add a methyl group, so a CH3, and on carbon 3 you would add another methyl group, so another CH3. Okay, awesome. Hopefully that wasn't too crazy. But let's get rid of all the writing. Let's be real organic chemists and be lazy about the writing, so we can be specific about our nomenclature and start blowing stuff up or whatever it is that organic chemists do. We'll talk about it later. So let's look at number 7. It looks insane. It's just a bunch of lines. How can this be something? But this actually tells us a lot. So number 1, we know that every end of the line segment represents a carbon. We know we need to find our longest carbon chain. What might that be? I'm going to start here and go 1, 2, 3, 4, 5, 6, 7, 8 carbons. Cool. Is there any other way I could go and get more carbons? No. If I went a different way, if I made a turn, if I said, well, let's see, maybe I can. If I go 1, 2, 3, 4, 5, 6. Oh, that's only 6. That's not more than 8. You know, surprise, surprise, basic arithmetic, whatever. Okay, so our longest carbon chain is 8. That makes this an octane molecule. Octane, yes, like the fuel, high octane, etc., etc. We'll discuss that later. Okay, so this is an octane molecule. This is our carbon backbone. So if you were to make this molecule, the first thing you would start with is an 8-carbon chain. So what else is happening? Okay. This one starts to get a little weird, because what is happening? We have our 8-carbon chain. Let's start here, and we'll name this, we'll number this carbon 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, fabulous. All right. So at carbon 2, we have, a straight line. What does that mean? That means there's one carbon here. If there's one carbon only bonded to one other thing, it must have 3 hydrogens. We haven't talked about double and triple bonds yet, so for now, that's good. So that makes this 2-methyl, because that's a methyl group. What else do we have? At carbon 5, something else is happening. What is happening? It's a little weird. Because if you draw your things, you go, okay, so here's a carbon and here's a carbon. Something weird is happening. So since this is a carbon and this is a carbon, that's an ethyl group. But what's happening with this carbon? We haven't talked about it yet. So for the sake of this assignment, we're going to pretend like this doesn't exist. Okay? Just to make this a little easier, so I don't want to give you too much to kind of blow up your brain first thing. So pretend like that little part doesn't exist, and we're going to cover it next time, okay? So if we were to just look at this, we would say, okay, we took into account the 2-methyl group, the methyl group on carbon 2, and then this is an ethyl group, because it's 2 carbons. It's on carbon 5, so it's 5 ethyl. Okay, so the name of this molecule, with our little edit, is 2-methyl 5-ethyl octane. I'm going to do one more with you, and then you are going to do numbers 9 and 10 by yourself. We will edit numbers 8 and 9 so that we take off this group. Oops, sorry about that. we're going to edit, we're going to take off this group, la 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 la, goodbye. We're going to take on number 9, we're going to take off both of these groups. They don't exist, pretend you never saw them. We're going to come back to them later, but for now we're going to pretend they don't exist. So for number 8, so 9 and 10 are homework, okay, 9, 10, homework, boom. Boom. And for our video method, what we'll do is I'll have you take a picture of numbers 9 and 10 and just email me that, and that'll be how I grade this if you end up not coming into class next time. All good. We have the technology. We can make this happen. So let's look at number 8. What is happening with number 8? Let me, speaking of technology, figure out what I'm doing. Okay, number 8. Again, it's just a bunch of straight lines. What is happening? We have edited it, so this does not exist. Excellent. Number 1 thing we need to do is find our longest carbon chain. Let's do that. I'm going to start here. Okay, 1, 2, 3, 4, 5. Let's go this way. 6, 7, 8 carbons. Okay, one option is that it's an 8 carbon molecule. What is another option? Let's just check and make sure. 1, 2. So remember, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. That's the longest possible chain, so this is a nonane. Nonane. Okay, that's going to be the carbon chain that this is based on. So the first thing you would do with this molecule is build a 9 carbon chain. Cool. Next, we need to number our carbons so that we hit the first functional group at the lowest number possible. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Rather than going from the traditional left to right, we need to go this way. Okay, so what are our functional groups? Here's a fun straight line. What does that mean? We know from the last problem that straight lines mean that this is just a methyl group. Okay, so at carbon 4, we have a methyl. Oops, I don't know why I added a comma there. Getting all comma crazy. There we go. So 4 methyl, comma, appropriately. Excellent. And then at the carbon 5, something else is happening. We have a 1, 2, 3 carbon group because we're ignoring that other one. So remember that 3 is propyl. So we have 4 methyl, 5 propyl, methane. Whoops, I'm adding extra letters. Sorry, not methane, nonane. 4 methyl, 5 propyl, nonane is the name of this molecule. Okay, you have everything you need now to do numbers 9 and 10 for homework. Remember that on number 9, we're crossing out these 2 extra methane, or sorry, I was right the first time. We crossed out these 2 extra groups. They do not exist, they do not exist, okay? But everything else does. So find your longest chain first, then name it. On number 10, 10 you don't have to edit, it's perfect the way it is. Just like you. And so please do numbers 9 and 10 for homework. Send me a picture if nothing else, and I will talk to you again soon. Bye, Mary Pat.